For a single displacement reaction, we decided to use the reaction between calcium and water, in which calcium replaces a hydrogen atom, creating calcium hydroxide and hydrogen gas. When we observe this reaction, we can see white paste forming on the surface of a calcium pebble. This white paste is calcium hydroxide, while the bubbles forming on the side too is hydrogen gas. When we take this pebble out and place it in a pool of water, we can obviously see that calcium hydroxide is still forming, but this visible smoke that we see coming off of it still is hydrogen.
Well, what we originally wanted to do was put cesium in water, but Mr. Winiger said he didn't have any cesium, so we decided to use a less reactive alkali metal that would give us the same effect in a smaller magnitude.
For our combustion reaction, we decided to use a firecracker. Although there are many other things that can be used to create a combustion reaction, such as burning gasoline or propane, we decided to use a firecracker that used black powder, which is a mix of potassium nitrate and ethylene cytopentadiene. When burned, creates potassium carbonate, carbon dioxide, water, and nitrogen gas. Within our firecracker, though, it contained other chemicals, such as sulfur and charcoal. The sulfur is used to create the big flash you see when the firecracker pops, while the charcoal is used to make sure when it blows up, it does not explode with such force that it'll hurt anyone that's around. What just happened was a fuse bringing a flame down to the gunpowder, rapidly igniting the gunpowder, creating gases such as nitrogen and carbon dioxide, which will quickly expand and explode with a popping noise as you just saw. For our decomposition reaction, we used a reaction between potassium chlorate and gummy bears. To make this reaction work, we first have to heat the potassium chlorate. When you do this, rapid decomposition of potassium chlorate occurs, producing oxygen. And then when you add a sugary gummy bear to this equation, it causes the sugar inside the gummy bear to oxidize, rapidly combusting the sugar over the course of the experiment. As this happens, purple flames are given off.
When you combine aluminum and iodide, the resulting acids dissolve the oxide film on the surface of the aluminum, which then begins to react with iodine. The reaction is then accompanied by an intense release of heat, which causes some of the iodine to sublime, causing the purple smoke or gas to form as seen. As you can see here, the purple gas is starting to form, and it even left a stain on the floor. The chemical reaction actually occurs in two steps. Firstly, there is a double displacement reaction in which acetic acid in the vinegar reacts with sodium bicarbonate to form sodium acetate and carbonic acid. Carbonic acid is unstable and undergoes a composition reaction to produce the carbon dioxide gas. This carbon dioxide then escapes the solution as bubbles. The bubbles are heavier than air, so the carbon dioxide collects at the surface of the container or overflows it. In a baking soda volcano, detergent can be added to collect the gas and form bubbles that flow somewhat like lava down the side of the volcano. A dilute sodium acetate solution remains after the reaction.